Hi, Birdbound. This is Chemistry Day 4. We're talking about balancing equations and types of equations. First of all, I want to tell you there are two methods of balancing. One that is very common called the table method, where you make a table to show the elements, the number of reactants, and the number of products in the equation itself. Then you add coefficients to the terms and you change the table until everything balances. Then there's this block method. I wrote this several years ago to help my freshmen get used to balancing equations, because once you see it, you will always see it. You write the equation in terms as individual atoms put in blocks. You look for where they don't match. You add blocks until they do match, and the layers of the blocks are the coefficients. You have four types of equations that we're going to deal with. Synthesis, where two things combine to become one. Decomposition, where one thing breaks apart to be two. Single replacement or single displacement. Both ways are acceptable, where one bond breaks and forms with the single, and a double replacement that's just big, where everything changes its position. So looking at this example, if we're going to do the table method, we recognize that we have sodium, calcium, and fluorine are elements. On the reactant side, we have 1 sodium, 1 calcium, and 2 fluorine. On the product side, we have 1 calcium, 1 sodium, and 1 fluorine. Okay? So if I add a 2 in front of sodium on the reactant side, I change my table to reflect that now I have 2. I also then have to add a coefficient to the product side and change my table to reflect that. But notice that the product also changes. The product of fluorine also changes. So you're going to have a balanced equation of coefficients will be 2, 1, 1, 2 because the table is completely balanced. This is a single replacement reaction because sodium was alone, chlorine or calcium was bonded. Now calcium is alone and sodium is bonded. Looking at this problem, Al2S3 becomes Al plus S8. You only have two elements here, aluminum and sulfur. You have 2 reactants of aluminum, 1 product of aluminum, 3 reactants of sulfur, and 8 products of sulfur. So the first place I'm going to start is where I notice I am down. I am the least. If I put a 2 in front of Al, I change my table to reflect that. However, now my sulfur is off. So I'm going to put an 8 because the common denominator between 3 and 8 is 24. So I'm going to put an 8 in front of Al2S3 on the reactant side, change my table so that now I have 16 aluminum and 24 sulfur. I then have to change the aluminum to be 16, so that replaces the 2, and a 3 in front of sulfur on this end on the product side to make 24. So your coefficients for this are 8, 16, and 3. This is a decomposition reaction. We'll do several in class. Thanks for watching.